Okay, well, hi, everybody. Welcome to the session IronRuby for the .NET Developer. My name is not Scott Allen. For those of you who saw the session in the open call for content, my name is Corey Foy. Scott Allen and I both submitted a bunch of IronRuby sessions. He got selected and decided to go to Scandinavia. Such is life sometimes. So this session will be an introduction into what IronRuby is and why you should care about it from a .NET developer perspective, and what kind of the Ruby language is all about. How many people are using Ruby now in some capacity? How many of you are full-time Ruby developers? Anybody? There's one. Who's a .NET developer? And what else is out there? Anything? That's it. OK, good enough. So let's start initially by just saying what is IronRuby and what really is Ruby all about. So we'll start by actually digging into a little bit of code here. So if I go and look at So can you all see that OK? I'll take your so the way this will work is if you don't say anything, I'm going to assume you're fine with it, and we'll make contractual obligations later. So this is a typical Ruby class. So Ruby is an object-oriented, dynamically typed language. And so we see here we're actually creating a class called Talker, and we have an adder accessor, which is effectively like a property in .NET. We have initialize, which is the constructor, and we've defined a method here called talk. And then in this same file, we're instantiating an instance of the object and calling a method on it, and then updating the object and calling the method again. So if we run that, you'll see what happened is it ran hello Corey and hello MIX10. So pretty straightforward. I think we can all understand the syntax of what this is. So what we're looking at here, this is straight Ruby. This has nothing to do with IronRuby at all. This is just the normal Ruby syntax. Now, we did run this through the Ruby interpreter, which means all of this was converted to the CLR before it ran. But the power of the CLR allows us to actually grab various objects from the CLR, from C#, from .NET, that kind of thing. So if we look at Hello World Ruby, this is the same exact class, but instead, we're getting the system date time instance. And so that is a CLR object. And if I run that, you'll see it turned around and grabbed the example from datetime. So again, pretty straightforward. The other interesting use of, well, actually, before we get to the other interesting use, IronRuby is not just about dealing with console apps and libraries. So here we're dealing with System Windows Forms class. So if I run this, we can instantiate Windows Forms instances as well. So hello world RFB. And there's our little itty-bitty Windows Form saying hello Corey. And then another one saying hello MIX10. The third interesting usage of Ruby within the .NET world is with Silverlight. And whenever IronRuby first came out, that was a real big push, was how do we use Ruby inside Silverlight? So you have IronRuby and IronPython, which are both dynamically typed languages that run in the DLR, and they're both capable of being run in Silverlight. So if we look at our Silverlight class here, oops, we'll do this. This is a very standard, so if I'll initially open the app XAML. So this is just a standard. If you've worked on Silverlight, you've done WPF, you know what the XAML is. It's pretty straightforward. But instead of a code behind and written in C# or VB, we have our code behind written in Ruby. So you see here we're getting the root element, and we're adding a text block to it, and setting the values of it. And then, let's see, so we can run this. CHR using the Chiron. And there's our hello MIX10. So this is all Silverlight. Yes, I am running OS X. Yes, this is using Mono. Yes, IronRuby is running on Mono with this, but we are using very native Silverlight integration with that. So that's kind of a very quick whirlwind of what IronRuby is and what the language looks like. So let's talk about a little bit of history of how we got where we are. So back in 2003, a guy named Thomas Sondergaard posted to the Ruby Lang list saying, you know what we really need? We need a Ruby implementation running on .NET, or that bridges over to .NET. Because the .NET world is large, as we've seen from this conference, as we see from a lot of Microsoft conferences. There's a lot of .NET developers. And it'd be really great to be able to reach out to them with Ruby and show them the power of the language. So Thomas created the first Ruby to .NET project. And that was followed up by a Ruby CLR project. The Ruby CLR project that's in the middle was funded by Microsoft and by the Queensland University of Technology to make Ruby run on the CLR. And you would think that that is what involved in IronRuby today, but it turns out it's not. John Lamb, who was hired by Microsoft in 2006, created his own Ruby CLR implementation. And the challenge that all of these had, and why it was so difficult to get a lot of traction, and why a lot of us thought, boy, this is just going to always be a niche, was that we were trying to run on top of the CLR. And the CLR is a very difficult thing to just pop a dynamic language on top of. And that's because there really isn't a lot of dynamicism to CLR 2.0. So for those of you who get confused, there's CLR 1.1, CLR 2.0, and CLR 4.0. .NET 3.0 and 3.5 were base class libraries that were added on top of CLR 2.0. So there is a pretty fundamental difference coming in with .NET 4.0. We have a new runtime coming in as part of that. But in 2.0, everything had to be compiled. And what we ended up with was a lot of magic making all of this happen. And to give you an example of the magic, let's take a look at this method. And this is from John Lamb's blog of something that he did to get a count. What he would do is whenever you would call the count method, Ruby has this thing called method missing, which we'll get into in just a minute. But he would catch that you were trying to call count, and he would walk into IL code to actually marshal values back and forth across the .NET framework. And as you can imagine, trying to do this across all of these Ruby classes, or thinking about all the possibilities people could use code, was a bit of a difficult challenge. So in CLR 4.0, we got this new thing called the dynamic keyword. So who has not heard of the dynamic keyword? Who's excited about the dynamic keyword? It's exciting. Woo! So if you haven't seen the dynamic keyword, this is not it. This is how we normally do object instantiation and object method calls. So here we're saying get calculator, so we're getting some instance, and we're calling an add method on it. And if we write this code in Visual Studio and we compile, it's going to want that add method to be available in the calculator class. Now, what we got in 3.0 and 3.5 was an interesting new keyword, and that was called var. So what was the difference between the code I just showed and this one? That's right, yeah. So the only difference is that the type inference happens at compile time instead of actually having to be declared. So there still isn't dynamic dispatch. The add method still has to be present on whatever object the compiler resolves the var to be. If we wanted true dynamic dispatch, what we had to do was this, which was reflection. And reflection is a nasty beast. So here we're getting the type. We're invoking a member that's on there, passing in an object array, converting the result back that we wanted. It's not a very fun way to have to write an entire language by doing this kind of thing. So in CLR 4.0, the dynamic keyword, we're effectively able to get the power of this by just typing that. So what happens here is that the dynamic type, so var is resolved at compile time. The dynamic type is resolved at runtime. And where that becomes very interesting is that in Visual Studio, that add method IntelliSense will say, well, I don't know what it is. It's going to be resolved at runtime. So it actually is not looking for that at compile time, but it's waiting until runtime to resolve it. And a lot of this became possible because of the work done in the DLR. So the DLR is the Dynamic Language Runtime. And it was introduced at MIX10 along with IronRuby. And it's a set of libraries that sits on top of the CLR to assist language developers. And what it does is standardize the implementation of how dynamic language writers implement dynamic languages on the CLR. And one of those, of course, and why we're here, is IronRuby. So IronRuby was founded by John Lamb. He was hired by Microsoft in 2006, and they announced IronRuby in 2007. And the goal really here was to make Ruby a first-class citizen and he rewrote his Ruby CLR project from scratch to take advantage of the DLR. So what is the DLR? So we talked about that, and what is this mythical creature that enables all of this wonderful things that we can do now? So the DLR, like I said, is a set of runtime libraries that sits on top of the CLR, and it consists of 3 modules. The first is the common hosting model. So this allows you to run dynamic code inside of your C# modules. So C# VB.NET, if I want to host dynamic language as part of it, then I'm using the common hosting model. And we'll see an example of that in a little bit. The second is the runtime. So this is where the dynamic languages actually are compiled, interpreted, parsed, and where we determine if we've called it before, where we can cache calls for performance, so we're not always having to profile them. And the third is the language implementation, so obviously the most important. And this is where the language implementers turn to create or parse the syntax of the language and whatever you've written into a set of abstract syntax trees that are then used by the DLR compiler to talk to the CLR. And what's nice is we can do this. We can take Ruby, talk to the DLR. The DLR can go over talk to C# or VB, which then turns around and talks to the CLR. And we can go right back up, too. We can have, through the CLR, talking to, say, C#, hosting the dynamic language runtime, and go right up into Ruby. And that's a very powerful thing, because when we start having the DLR and the CLR, and we have static language, and we have dynamic language, and we have everything coming together like that, it's a really big love fest. And love fests are exciting. So the question I'm sure a lot of you are asking yourself, and I know I talked to a couple of you of why you're here, is why Ruby? Why should you care about what Ruby is as a language? After all, we have C#, we have VB.NET, we have JavaScript, we have all these great languages. Why should you care about Ruby? And the reason that I would give to you in 3 words is that Ruby is love. I'm surprised you all did not walk out at that time thinking, I don't know what's wrong with that guy up there. Here's why Ruby is love. This is a conference for designers and developers. And so a lot of focus here is about design and about usability. And if we think about what design is communication. A really well thought out design, a really great user interface is all about communicating intent to users. Us as developers, our job is to communicate the design of our code to other developers. Most of the work that we do is reading code, unfortunately. Most of the practice we do is writing code, which is probably why we're all so bad at what it is we do. So where I love the power of Ruby is that you can do a lot of expression of your intent as opposed to just having to do heroics of jumping around what the language is forcing you to do. There's another reason why I say Ruby is love, and that's some of the frameworks. So Rake is the build system that's on there. Cucumber is a testing framework that's on there. We talk about duck typing. We talk about monkey patching. How can you not love something that brings those kinds of things to the table? I do. You may not, but hopefully by the end you'll be convinced and be just as willing to hug Ruby as I am. But here's the thing. I know that a lot of you are saying, we're skeptical. That whole dynamic language runtime thing, I really like my type safety, and I really like the static code analysis, and I love the IntelliSense that I get from Visual Studio, and all this safety. I want safety. I want to feel secure that when I type Control-Shift-B, everything's good, and we can ship it. If it builds, ship it. That's the way I look at it. It compiles, woo, ship it out the door, give it to our customers. And that, static typing rules, it's awesome. It's performant. It's all of these great things. And we've had that kind of discussion before of language wars. We always have language wars. And what I'm going to say to you about static typing versus dynamic typing is very little. I'm actually going to sidestep the whole thing with a picture of this guy. His name is John Lark. He works for a company called HashRocket. And many people have said this, but what I love about HashRocket, they're a Ruby on Rails development shop. And they stand up in front of huge Ruby conferences, and he says, the reason why we can use Ruby on such large scales is because we do 5 words, and that is test all the freaking time. Ruby conferences are a little looser than we would be here, and I'm being videotaped, so I don't think we'll use the actual words he used. But it's all about test-driven development. And if we write a little bit of test code, a little bit of production code, and we go back and forth, writing a failing test, making it pass, and taking these small steps, we get a lot of that safety that the compiler gives to us, and the unit tests help us make our code change. But I won't spend too much time on that. Another topic I'm going to kind of veer away from is the performance aspect of it. So yes, we're talking about interpreted code. It is interpreted versus compiled code. Yes, it is a little slower. Now, most of that cost right now is in the startup time. So if I actually ran, let me show you an example real quick. So I'll back out of this. CD. So our Ruby that we ran here earlier, so hello world. So when I run this through IronRuby, you see there's a little bit of delay while there's startup. If I run this through the Ruby interpreter, it's instantaneous. So there's a startup cost because we've got to initialize a bunch of classes. We've got to build everything onto the framework. And that is something that the DLR team is working on because once you're past that startup time, it turns out to be a very fast language. Instead, what I want to focus on is the really cool thing of why you should care about Ruby. Because as it is right now, all I've shown you is, great, I can create classes. I can call them. I can make instances of them. I can do that in C#. And all I know now is that Ruby has cool project names. What do I care? The powers in metaprogramming. So in Ruby, all classes are open. All definitions are active. So everything becomes this really interesting way of being able to evolve a design at runtime and inject behaviors at runtime to give some very powerful or amazing amounts of power to you as a developer to write expressive code. So if you've used something like Active Record, so if we're dealing with a database, we can say when we have a first name and a last name in our database, Ruby at runtime, because of this ability, you can say my object.find by first name, and it can figure out how to resolve that without you ever having to define those classes. And we'll show you how to do that in just a little bit. But first I have this question. What is this? Now, you actually have to answer this question. I'm sorry. What is it? Duck. Yeah, of course it's a duck. What is this? Well, darn, it's a duck. And what is that? Somebody who's not paid well enough for whatever it is that they're doing. We all count these as ducks. And the interesting thing about ducks is that there's all kinds of them, and we can't tell what kind of duck we're talking about without some context of what we're working on. So in Ruby, what we do in this, instead of saying, well, these are three different ducks, we say, well, if you're a duck, I just want to be able to know that you can quack. And so within Ruby, we have this thing called duck typing. So this is one of the first and important elements about Ruby. So let's show what that looks like here. So let's say I have a class called car, and it has a method called drive in it. And that method, we have a very fast car that goes vroom. And let's also say that we have a truck. I'm a truck person, and that's part of what I get for living in Florida. And it goes roar, because I need a new muffler. So what we've done here is define two different classes. And if what we want to do here is, let's say we want to open up a racetrack and race a vehicle, all we want to care about is that the vehicle can drive. And so you can see where this is going if you've used JavaScript before. It's very similar. So we'll create some instances of our object here. Oops. Truck.new, and we'll create a racetrack. Racetrack.new. And so here we can just say track.race and pass in our car, and track.race and pass in our truck. And the reason that we do this is because Ruby doesn't care about interfaces or implementations or anything like that. All it cares about is that this object that was passed into the race method here has a method called drive. And it doesn't matter what that drive does. In fact, if I created a class called golf club that had a drive method, put s swish, and golf club.new, and I said, track.brace golf club, it's going to happily do that. Now, of course, that doesn't make any sense, but effectively, Ruby doesn't care. So that power of duck typing allows us to resolve things at runtime and do some very powerful features. Another thing is open classes. So in Ruby, as I said, all classes are open for definition. So let's go back to our method here. So if we have hello, there's a method called downcase, which is effectively to lower, as it would be in the runtime. In fact, I imagine that's how it's implemented. But if we wanted to do something, we wanted to add another method to the string class, we can do that. So the first thing we can actually do is say string.methods.sort. And when we type that in, this spits out every method that the string class responds to. And we can see there's a ton of them. And all of these capital letter ones, which don't look like Ruby syntax, are all the .NET ones that it's capable of running. But we can inject here at runtime new behavior to that class by simply reopening the string class. So I can say class string define say hi, put s hi self. And if I then say .methods.sort, oops. Try that again. .methods.sort. What we'll see here is that our say hi method is right here. So now it's been injected as a behavior, a first class behavior of our class. And I can say Corey.sayHi, and it's added there right as part of that. So that ability to add classes at runtime and reopen the definition of the classes leads to some of the really powerful features that we have. And the first very powerful feature that we have is called monkey patching. So monkey patching is not necessarily a good thing. It's not something you always want to be doing. That's why it's kind of not a great term to use. It's not, oh, we love patching or something like that. It's called monkey patching for a reason. And what it allows us to do is redefine behaviors of classes. Go ahead.
It's also called duck punching.
Duck punching.
Which is a more violent term.
Yes. Duck punching. Or developer punching if you find your developers doing this. But it allows us to redefine and retweak the classes to make them do whatever we want, like make them do our bidding. So if we wanted to redefine, so that toLower method that we saw just a minute ago, say we wanted to be really tricky. We can say define class string. And the first thing that we can do is use this thing called alias. So what alias is that it allows us to basically rename a method. So I can say alias downcase. And what I just did was that anyone who calls downcase is gone now from string definition. And if you call alias downcase, you'll get whatever code was written for downcase. And what I'm going to do is redefine downcase to say return no downcase for you if self dot equal Corey. And otherwise, we're going to call alias downcase. I did something bad there. It's not a demo if things don't go horribly wrong. String. Oh, yeah, you're right. Sorry. Class string. Code typing is only fun whenever you have to watch it once. When you have to watch it twice, it's no fun. Turn no downcase for you if self. Good friend of mine, Corey Haynes, says typing is not the bottleneck in software. Right now, I would beg to defer. Case end. OK. So now if I say hello.downcase, we'll get the same exact behavior we got before. Oh, well, whatever. we would get the same exact behavior before if I didn't have some sort of typo in here. And if you understand the concepts of what's going on here, which is that whenever we instead pass in Corey, it would say no down case for you and reject the actual down case. So there's some interesting uses of that, which allows us to do things like access HTML DOMs in interesting ways. So when we're opening up CLR classes, we can redefine the behaviors to make them more interesting, or do things that are more intuitive. So the other thing with dynamic classes is that we use this thing called method missing. So method missing is what happens when I call a method on a class and that method doesn't exist. So when we had our racetrack before and we passed in a car or a golf club or whatever, if I passed in a person that didn't define a drive method, what that's going to do first is look for a thing called method missing. And I know that code is hard to see. But it's going to look for this thing called method missing. And what method missing allows us to do is create more intuitive how we write our code. So let's go to our Silverlight example here. And actually, what I'm going to do is create a new Silverlight example. IronRuby Silverlight scripts. Ruby. OK. So this is a standard Silverlight application that we saw before. And I'm going to look at the Ruby method here. So what we're doing is we've got our root that we're getting from the application root visual. And then we're looking for the message. And then we can a message user control or message control, and we're setting the text property of that. But the problem is that anytime we want to sit here and say, any of the controls, we have to say @root find name. But if we change this instead, we can say define method missing m element equals @root dot find name m. And then we can say, yeah, good enough. And then we can change this to simply say @root.message. So now our code is a lot more expressive. We're not having to deal with the whole find name and passing in strings. We can do dot syntax to just access our app. And this becomes really powerful for things like JSON access or XML access, where instead of having to do all of these element searches, we can just use dot notation to work through whatever it is that we're doing. Come back. There we go. So last is dynamism. So whenever we take all of these things, we take duck typing, we take the ability to do all of these interesting metaprogramming topics, we start being able to create some very interesting dynamic classes. So let me open up this greeters class here. And if you see, we have two methods, or this method called greet and make greeting. And what we're doing here is creating creating class methods on the fly in our classes. And so if we look down a little further, here in our person class, we're saying greet in French is bonjour, and greet in Spanish is hola, and we're defining new methods that are in our class. So you see here, down here at the bottom, we just say person.greet in French, and it just works. So I say greeters, and it just works, just like that. And that's because of a lot of the metaprogramming. So here we're saying singleton class eval, define a new method, and we're passing that in as a string. So greet in whatever language was passed in, and then we've got a block that executes the code of whatever was passed in there. And so if we look at the methods of the person class after we've run that, suddenly we have 4 new methods that are added. And so that's all well and good. And let's see if we have the sound on. We do. So at breakfast this morning, samples IronRuby, I ran into the guys on the Microsoft Translator team. And they were talking about the new the Bing Translator APIs, which are pretty interesting. And so I modified this sample, the make greeting, to add a bunch of nasty-looking code. But effectively, it's the same thing, but what we're going to do is speak the greeting as opposed to just, just being boring and typing it out. So if I say IR greeter, greet voice, it should go.
Bonjour.
And it did that by accessing .NET classes. So here we're saying we're defining a path. We're calling system URI new, web client new, and client download data completed. So now we're attaching event handlers. And we're calling download data async. All of these things that we're calling here are .NET classes, .NET methods. And Ruby translates them back to the more familiar syntax for the .NET developers. And then what we're doing whenever that download completes is we're writing it out to a file in a binary way. And we're simply executing using system diagnostics process start info. Yes, I am calling process start info and process start on a Mac in Mono. And to execute AF play of the resulting wave that comes out of it. So pretty interesting things that we can start doing with Ruby and allowing our code to be able to write some quick, fun kind of demos. OK, so the last interesting thing about Ruby, well, not the last interesting thing, but is Ruby gems. So Ruby gems are a standardized packaging system for hosting packages. So if you write some snippet of functionality that a lot of people want to use, you can, or that maybe only you want to use, but you want to be able to access it in a standardized way, you can package as a gem. So gems are a standardized packaging system. It's a central repository for hosting these gems, and then anybody can turn around and pull it down. And the important thing, it allows for management of multiple installed versions. So most anything that we do in Ruby, whether that's Rails, whether that's Rake, whether that's accessing HTTP classes, almost everything is we pull down the Ruby library, and then we're able to do gem installs. Now, the lucky thing you have from IronRuby is that you're not only getting access to most of the Ruby classes, you're also getting access to a lot of the .NET framework that's there, and that's pretty powerful. So with Ruby gems, literally it's just gem install and HTTP party. HTTP party is a phenomenally fun gem to use. And then that's it. And it's installed, and you turn around and start using it. And this resolves any dependencies that your gem has. So if you're using other gems, it'll pull all of those in. It'll do the installation and configuration right there for you. OK, so enough about Ruby. All of that, almost everything we've showed before, except for obviously the .NET runtime, is all compatible across Ruby. So what about IronRuby? So let's look at the basics. Installing IronRuby, you go to ironruby.net/download. You download the Windows installer, unless you have a Mac, and you profit. And that's it. And you have it installed, and you're able to turn around and start running IRB or any of the Ruby code. You can execute it right there with IronRuby. So what happens when we install that? So let's very, very quickly take a whirlwind tour of what it looks like. So this is release candidate 2. So we have a bin directory, which includes some DLLs. So the IronRuby libraries, YAML DLL, the dynamic DLL, and the scripting DLLs. And then we have a bunch of various programs. So we have iGem, which is our Ruby gem. We have IR, which is the Ruby interpreter. We have IRB, which is the interactive Ruby interpreter. Rackup, which allows you to run Ruby on Rails on IIS. Rails, which is our Rails command. Rake, which is the Rake command, so on and so forth. So all of that comes right there as part of the bin directory. In the lib directory, we just have some classes. So within the Ruby directory, that's our standard Ruby library. But in IronRuby, it's very interesting. So you'll see here we have a lot of .rb files, but some of them look familiar, like presentationcore.ruby. Wouldn't it be awesome if we could just say presentationcore.ruby and get access to whatever they've written for presentation core? But what this actually does is it's a shortcut for including libraries. So anytime you require or you use .NET libraries as a part of your application, you need to include the full strong named, if you're using a strong name assembly, obviously, you have to do the full strong name. So what the IronRuby team has done here was create shortcuts. So all I have to do is say require presentation core, and this Ruby file turns around and requires the whole strong name, so I'm not constantly having to type all of this out. So thanks, guys. That was a brilliant move. And lastly, inside of the IronRuby install is Silverlight. So this is the Silverlight Dynamic SDK, and this is what allows Python or Ruby to run or allows you to write Silverlight code behinds in IronPython or IronRuby. We have the bin directory, which has all of our DLLs as part of it. We have the script directory, which has the two main things here are CHR and SL. CHR is if you've done Silverlight at all, it's the Chiron. It starts up a web server. It automatically creates a zap file for you and deploys it. And SL generates that Silverlight it's almost like a Rails command for Silverlight, and it creates a standardized kind of layout for a Silverlight application. So that's the whirlwind tour through it. Yes, all those things are great. Yes, and the samples, because the samples are very cool. So how did it do that? So what happened whenever we ran these examples that turned around and accessed the DLR, the CLR objects? How does it work? So we already looked at the DLR and the common hosting model, the runtime, the language implementation. And what we first start off with is this runtime. So when we process the Ruby code or we process Python code, it goes to a set of binders. And the binders are responsible for figuring out what to do with it. And the two things on either side are the call sites and the rules. So the call sites effectively are a caching mechanism. So if we're doing a loop, we don't want to necessarily interpret the loop every single time. There may be things that aren't for that. So we can cache those calls to help improve performance. And the rules help figure out when we cache and when we don't, because obviously there are times when you don't want to do that either. So the rules are what allow the behavior to figure out when to cache and when not to. The next thing is, of course, the more interesting part, which is the language implementation. The language context is what the language context is. It's the language and everything about it. The compiler is what's responsible for taking that, parsing it, and into the abstract syntax trees, which are then used by the DLR compiler to access the CLR. And lastly, we have the common hosting model. And so these are the various methods or various objects that you would use if you're hosting IronRuby as part of your application. So enough about slides. Let's look at some integration points that we have with our application. Oops. OK. So the first is calling .NET from IronRuby. So we've seen what we're able to do with calling .NET from IronRuby. Oh, darn. That's what I was going to do. I was going to save the translator for this part, so you all have already seen it. That's OK. So we'll just briefly talk about what's in this code. So you see at the top, we have require system Windows forms. So what that's including is that system Windows forms.rb file, which includes the strongly typed name system Windows forms DLL. And then this is the syntax that we use, system : Windows : forms. And we can bypass that syntax by just saying include system Windows forms. And now we can just say messagebox.show. So pretty straightforward. And the other thing, of course, in Ruby is that we don't need any of the parentheses at all. So we can make it say talker.talk. And all this would still work. So pretty straightforward of what we're doing with .NET from IronRuby. Now, if we want to call IronRuby from .NET, so this is if we want to actually host IronRuby. Shay Friedman, whose books I have up here, and if you want one, just see me afterwards, has an example of an integration called extendable app. So this is called MonoDevelop. Look, it's C# code. Aren't we all excited? I don't know who's VB.NET in here who's like, no, boo. So what he has done here is created a form which allows you to test out, what dynamic language hosting looks like. So I'll show you the form first. So this is pretty straightforward. No dynamic language at all. We can just say send. It says hello, Corey. But if we click at extensions, we have this extensions writer. And what this is doing is allowing us to dynamically execute code inside of our Windows Forms app. And we're doing this using either IronRuby or IronPython syntax. So I'm going to say hello form.name text box. And if I save and close this and I click send again, it'll say, hello, system Windows Forms text box. All right. So what we need to do is say .text. Save and close. Send again. Hello, Corey from IronRuby extension. So how this works behind the scenes is pretty straightforward. So if we look at the rest of the application here, it's a standard Windows Forms app. So we have a form class. It's got text boxes. It's got, yay, whatever. And if we look at the extension form itself, again, nothing special except for he's setting some default Ruby code. The power of this comes in the extension runner. Let me close this out here. So first we start by saying, including Microsoft.scripting.hosting, IronRuby, IronPython hosting, and the Microsoft scripting. So these are the classes which allow you to run either IronPython or IronRuby code as a part of your class. If we scroll down a little bit here, there we go. We'll see how we did that is by this script scope. So we create a script scope and a script engine, and we can either create a Ruby engine or a Python engine. And so here he's just doing a swap between them. And we're actually passing variables into that engine. So of course, when we create the IronRuby context, it doesn't have access to our variables because it's a whole different thing. But what we can do here within this scope is pass in variables that then are accessible from our IronRuby code. We say engine create script source from string, which is a very interesting evaluation statement, if you will, and then turn around and get the return value out of it. But if you notice, we're not setting the form text box or anything. All of that was done from the Ruby code because we're passing the reference to our objects to Ruby, and Ruby's actually executing against those objects that are part of it. So that is a pretty interesting scenario for just hosting the code in whatever this is, 40 lines of code. Suddenly you're able to host Ruby in as part of that. A good scenario for thinking about why in the world you want to do this, and not just for saying, oh, we can make our app insanely dangerous and they can access anything, is thinking about from configuration. So I was talking yesterday or last night to somebody who works for a company which pushes out a lot of software. And they have an XML scripting language that they use. And any of us who have worked with XML, now that 2003 is over and it's not as exciting, know that that is a very painful thing. Like he was saying, well, we can only have 3 nested if loops. And nested if loops in XML? I don't even want to think about that. But what we can do with this is instead say, here, let's put our configuration files inside of Ruby. Like, let's write them in Ruby. And with this, with the ability to be very expressive of what we're doing, suddenly it makes more sense for those people who have to go in and edit these. Now, you have to be cautious because you have a lot of powerful, you've got a scripting language you're writing with in that context. But it still becomes a very interesting use case. So the last thing I want to show you is Silverlight integration. MIX10, OK. Silverlight scripts. So I wasn't going to do a Twitter app, but apparently that is the new Hello World. And when I saw it at the keynote, I didn't have a choice but to do that. So here is our Hello World Twitter application. And you'll see what it does is it goes and it searches Twitter, and it fades in and out. It keeps it up there for 10 seconds. It pops up, pulls our image. Fair note, I am not actually hitting Twitter. I was, and I found out Twitter rate limited the conference about 5 minutes before my talk started. So I swapped this to, luckily I had a file cached, but I can show you where the code is that swaps this out. But this is Silverlight that we're running. This isn't some magic. This is Silverlight. We're going right through the .NET framework, and we're turning around and able to spit it out, do all of our, so we're doing animations here in Silverlight, and we're controlling all of that code through Ruby. So let me show you what that Ruby code looks like. OK. So first I'll start with our XAML. So the XAML is pretty straightforward. We have a couple of storyboards that we use for timers. And then we have our grid of the root. So we're just doing the layout here is what we're effectively doing. And then we have the interesting part. So we define a class called tweet, which has the author, the text, and the image as part of it. And then we have our normal application. So here we're calling, this looks familiar, I'm sure, from before. But we've got our message canvas, author. Here we're starting up timers. So we're finding the various timer animations. And see timer animation not completed. So we're again, attaching event handlers straight through Ruby code. So this is a different syntax. You may have seen the timer animation completed do. You can do it either way. This is kind of a one-liner to add a event handler to whatever it's going to run. And if you think about what's happening behind the scenes with this, is that this is timer animation. These are .NET objects. Timer animation is a .NET animation object. It's a storyboard. And we're calling the storyboard completed object. And normally you would say storyboard completed plus equals. And we're doing this with Ruby blocks and turning around and passing it in. So it's a very neat thing to think about. And then here we're doing our search. So you see the first URL is commented out, because that's where we actually went against Twitter. And we're just doing a new web client. Open read completed, same thing. We're passing that out, calling read async. Here in read complete, we're streaming in the response. It says parse response XML, but it's actually JSON. And if I pass down to here, so parse response. System JSON value is a system JSON DLL that came with some of the samples that I found to make JSON parsing a lot prettier. And we're just parsing those out. So I mean, the code that we're using here is pretty straightforward. And then here on show next tweet. So here what we're doing on show next tweet is we're popping the next one off of our queue. We're calling the tweet animation and stopping it, setting the target name to our new animation. I didn't have to do that, but that was from an earlier iteration. And then setting the author message and image text. Again, bitmap and image.new, that's our .NET class to set the image source for our image control. And then just beginning the animation. And we're doing all of this from Ruby, but we're talking to Silverlight behind the scenes. So a pretty neat thing here. It's mad now because I shut off the server. Oh, OK. So one last, I would be, I brought up Cucumber, so I should talk about Cucumber. Cucumber, so there's, in the Ruby world, there's two, so if we look at .NET, so the way that we have to unit test in .NET is we have NUnit, we have XUnit.NET, we have MBUnit, we have the MS test. In Ruby, the real power, and this is starting to come over now to the .NET world, is you have test unit, which is your standard unit test. You have RSpec, which are for writing specifications, and it's a little more core to the metal. And then you have Cucumber. And Cucumber is this cutesy sounding name. And let me show you why. Because it's a cutesy looking application. So if we look at, so this is a standard Rails application that I have. But this works just as well as in .NET. I just happen to have a more complete example here. Let's look at our security feature. So what I'm doing is I'm building a web application, and I'm defining the specifics of that web application using effectively plain text. Now, don't let this fool you. This is not plain text. This is a language called Gherkin, after Cucumber. And you don't use Pickle to run it. But, and we're saying, so I can protect my great ideas as a registered user. I don't want anyone else seeing my tasks. And I define scenarios. Given I go to the home page, then I should not see new tasks. Given I'm not logged in and I go to the new task page, then I should be on the login page. So the syntax that we use here is these given, when, then scenarios that we can write the specifications of our application. And what happens behind the scenes is that those become executable. So if I look at our to-do steps, given a task called blank, do task name. So we're using regular expressions to set or to capture what happens when they're run, and then run various codes with it. So let's see, I want to, security's probably, yeah, when I log in. So here we're saying when I log in as whatever the username is with password or whatever, and it passes these as parameters. And so this is a tool called WebRat. So I can say I visit the home page, click the link login, fill in login with user, fill in password with password, and click the button login. So it becomes this really neat thing, but effectively behind the scenes, we're executing our application and turning around and running code and testing to make sure everything's working. And just to show you what that looks like. Oops. So I can run, an extra slash there. When I run the features, what it'll do is actually execute the features against our application. And what it'll do is spit out that everything looks great. Tasks belong to user. Given a user called Corey with password 3456, and these tasks, when I go to the home page, then I should see those tasks. And if it's not working, then we know very quickly that it's broken and where it's broken, because all of these won't be green, they'll be red or yellow or whatever we're doing. So that is Cucumber. And within .NET, so even if you don't want to, even if I have not convinced you to look at Ruby and you run out of here screaming, going, I can't believe I wasted an hour in that session, this is a very powerful framework that you can use in .NET code. So there's a couple of open source libraries that have come. So Cucumber has one called Nuke for Cuc, which allows you to write Cucumber and run Cucumber against C# libraries. There's SpecFlow is another one that's out there. So there's a couple of various frameworks that allow you to write Gherkin code, which is what this is called, and execute it against C# libraries. You don't have to just do it in IronRuby. OK, so last but not least, get involved. So one of the most powerful aspects about IronRuby is that, and IronPython, is that they're community-driven. So there's a team at Microsoft who's working on this. Jimmy's one of them who's walking out the door. Bye, Jimmy. He's got his talk at 1:30. So after this, go see his talk. He's a much flashier presentation. And they're at ironruby.net, and they have a very active mailing list, and they accept code contributions from the community, and they've worked out a way to integrate those patches into the great Microsoft process. So go out to ironruby.net, go to ironruby.codeplex.com or github.com/ironruby. You can pull down not just the binaries, but the source of it, and run it and play with it and do whatever it is you want to do. And sign up on the mailing list to execute it and to let them know what things are going on. So the IronRuby team is in release candidate stage right now. They just released release candidate 3 about 3 days ago. And so they want you to really play with it. And if there's bugs or you're seeing weird things, sign up on the mailing list and certainly let them know. And so last but not least, my own self-plug. The slides will be up at blog.coreyfoy.com after the session. And of course, you can see them on the website and all that other stuff. And so with that, I thank you very much for your time. And if there's questions, anybody? Go ahead. If you want to use the mic, if you don't want to go to the mic, I'll just repeat it. So it's completely up to you.
Hi.
Hi.
I kind of think that maybe a lot of .NET developers mostly look at Ruby as a sort of toy, a funny little thing. Do you use it in production? Do you know anyone who uses it like seriously?
So from an IronRuby perspective, yes. There are a couple of people who are using this in production applications now. And of course, with the Silverlight support, that is a much larger fan base, because now you're able to run that wherever Silverlight is. You're able to run Ruby code or Python code right as part of it. The IronPython implementation is more mature than the IronRuby one is. So there's more applications that are run against IronPython than IronRuby. Especially once IronRuby hits 1.0, then it's more stable. I think we'll see a lot more applications coming against it. Now, Ruby itself, there's tremendously large applications that are written against Ruby that are out there. Oh, go ahead.
Hello. When you listed the methods for that string, I noticed a Pascal case method called switch to mutable. I wonder what it does, because .NET strings are supposed to be immutable, and if that method actually does something interesting.
It's just for interacting with the CLR. So right, it is. I don't know exactly what that does, and of course Jimmy just walked out, but that is probably only there for the .NET integration, because that's certainly not a core part of the string class. So I would imagine that that's ability. So a lot of times whenever you're taking Ruby code and you're interacting with .NET libraries, sometimes you have to effectively say, I want to take this Ruby string and convert it to a CLR string.
Right.
And so that is a common thing that you end up doing when methods are picky about it. You can convert it to a CLR string and then pass that over to the CLR.
Right, I was just wondering if that actually makes the string mutable or not, which would be kind of interesting.
Yeah.
Hey, just a couple of quick ones. But you mentioned that there was a startup penalty for IronRuby. Can
Yes.
that be offloaded to program startup?
Yeah, absolutely.
Okay.
Yeah.
And then the other one is, so is there IronRuby support in like Visual Studio? Do you guys have any templates, IntelliSense, coloring, anything like that for Visual Studio for IronRuby?
So not in 2008, but in 2010 they're working on providing the IntelliSense and things like that for it. So IntelliSense is a tricky thing with dynamic languages because there is one called, there's a couple of IDEs, Ruby IDEs that are out there that are providing IntelliSense support. It's a very tricky thing when you start talking about what it is that you're doing. So yeah.
All right. Oh, actually, one other one.
Sure.
Is obviously being able to access your program in the way that you described. You kind of mentioned there were some security risks involved. Are there ways to limit what classes or not what classes, because you have to provide the classes if I'm not mistaken through
right.
But what, like, are there ways to limit what methods or limit properties?
So you can't do anything in Ruby that you can't do in .NET. So that just to be clear about that, it's not like there's some magical ability that it gives to you. Everything still goes to the CLR, and all of the CLR security methods still come into play as part of it. When you're hosting the code, it only has access to the objects that you give to it in the hosting model.
Yeah, hi. Just wondering where IronRuby is with respect to the Ruby 3.0 with the convergence with MERB.
The Rails 3.0 stuff.
Yeah.
So what Jimmy said was that they are running all of the Rails 3.0 tests, but that doesn't necessarily mean it's working well. But right now IronRuby is passing all of the Rails 3.0 tests.
Okay. And second question is just I saw your Twitter app there that you've written. Just kind of wondering is there like almost like a template for building Twitter apps? There's so many of them.
That Twitter app took me all of about 15 minutes to write. So
okay.
It was. Twitter makes it dead simple to pull in JSON or XML and just parse it.
Okay. So quick third one. If you were to write that with MVC .NET, the latest MVC 2.0,
yeah, right.
How long do you think that would take you compared with writing it in Ruby?
So I'm not going to touch that because it all depends on what you want access to. So if you're talking about Ruby on Rails versus ASP.NET MVC, it all depends on what you want to have access to.
Just say a simple fire and forget app.
So it depends on if you have Visual Studio installed. So if you have Ruby installed, you can just say Rails and the name of it, and it generates a Rails app, and you can script server and start it up. With Visual Studio, you say new ASP.NET MVC project, and you hit run, build and run, and it runs it. So if you're just talking about something simple, they're probably about the same.
Okay, thanks.
You're welcome. Did you have a question? Or did it get answered? Yes. So the question is if Rails is supported? Yes, Rails is supported. So the iRack that you saw helps run Rails on IIS. Sure. No, it's packaged. So the question is, does the user have to install Ruby? They don't. It's packaged as part of your zap file that comes down. Okay. Well, thank you for your time. If you're interested in one of these IronRuby books, and do that. Do the feedback thing. Fill out one of the forms. Give it to the back. It's a great way to let us know how everything went. So, thank you very much. Have a great day.